Hi, this is Summer. This is my recipe 8. So here I need to work on MNIST dataset using autoencoders and decoders. Let's see how the model plays. First I have to import the libraries and load the MNIST dataset right here into the input frame and a target frame. Input test and target test. So here is the size of the data, 60,000 trial and 10,000 test. So since the model takes so much time for learning, so I have reduced the number of training and testing data to 10,000 and 1,000 respectively. Uh, Here I'm training the top 10 images of the training dataset. So here are the here's the reduced size. You can see 10,000 and 1,000. Uh, Here I'm configuring the model. Here I have set the image size, width and height as training, shape 1 and shape 2. Batch size of 128, 50 epochs and 20% split. Number of channels 1. And here I am normalizing the data since it may be parts with numbers as flow. And here we're creating the encoder. Encoding. Here is how the encoder definition is. The first layer is the input layer and the second is the convolution 2D layer with filters just right, and the activation function is ReLU and performing batch normalization and increasing the number to 16 filters, and again batch normalization and flattening the data here and using dense function with ReLU and again normalization with followed by 2 mu and sigma dense layers. And here is to retrieve the shape of final convolution to the output. And here I am defining a sample with a reparameterization trick. And here we use the lambda to ensure the correct gradients. And this is the whole model that discussed in the classroom. Here is a summary of it. And initializing the decoder, defining the decoder here with input layer and the second with dense followed by batch normalization, and again here reshaping and followed by convolution to the transpose layer and filters up to number of channels. And here I use sigmoid activation, initiating the decoder here. Here is how the decoder output is 28, 28 and 1. And here I am initializing the variational autoencoder. Here, here is how it is: 28, 28, and 1. And it's time for compiling and training the model. I've used Adam apt optimizer and cross entropy loss function, binary cross entropy. And here is the model. I have the loss of 17% and a validation loss of 19%, which is not bad. And here is the output. It maps against the images. I did pretty good. And for initializing the new model, I have changed 2 layers. I have added convolution 2D layer with a filter size of 256 and added one extra batch normalization for like stabilizing the learning process, thereby reducing the use of echoes. And the more the filters, the more the complex information the image get. Convolution 2D shape for 2D transpose, and the same thing sampling with reparameterization using lambda function, and again reinitiating the encoder. Here is how it goes. And initiating the decoder function here. Here I have added the same thing, one extra layer of batch normalization and one extra layer of convolution 2D transpose of 256 filters. And here is how the model goes. Decoder summary 28, 28, and 1. It is output decoder, and initiating the VAE autoencoder and fitting it. Here is the loss of 19%, validation loss of 19%, and here is how the model here is a visualization. I did pretty good. To map against the images from 0 to 9. Thank you.